Dear friends, good morning to all. Myself, Dr. G. Sivayalongo, Assistant Professor, PG and Research Department of Biochemistry, Sacred Heart College, Autonomous, Tirupattur. Today we can discuss about enzymology paper. Under the enzymology, very important one topic, Michaelis Menten equation derivation. Derivation of Michaelis Menten equation. In an enzyme catalyzed reaction, a free enzyme E binds its substrate S to form an enzyme substrate complex. The bound enzyme are called as enzyme substrate complex, which either undergo further transformation to yield final product P and the free enzyme, or otherwise break down reverse way to form free enzyme as well as substrate. The reaction for enzyme plus substrate in the presence of rate constant K1 to form the enzyme substrate complex, and reverse reaction in the presence of rate constant K2 to form enzyme and also substrate. Otherwise, enzyme substrate complex further proceed to form in the presence of K3 rate constant, finally free enzyme as well as product. The starting point is the catalytic rate we consider as V naught is equal to the product of concentration of enzyme substrate complex and K3. Here V naught equal to K3 into enzyme substrate complex concentration. Here the rate of formation of enzyme substrate complex equal to K1 into enzyme concentration and substrate concentration. Here we consider as this is equation 1. Next one, rate of breakdown of enzyme substrate complex equal to K2 into enzyme substrate complex concentration plus K3 into enzyme substrate complex concentration. Here enzyme substrate complex are common one. Now we can take out. We are getting the K2 plus K3 into enzyme substrate concentration. This is for equation 2. At a steady state condition, the formation and breakdown of enzyme substrate complex, the rate of formation of enzyme substrate complex equal to rate of breakdown of enzyme substrate complex. Now we are substituting both the things. K1 equal to enzyme concentration into substrate concentration equal to K2 plus K3 into enzyme substrate complex. Here this equation we are rearrange it. Now enzyme substrate concentration alone we are kept in one side, remaining are goes to another side. Now the enzyme concentration into substrate concentration divided by K2 plus K3. Here the K1 further we are divided means goes to top one. But K2 plus K3 divided by K1 we are consider as Km, Michaelis Menten constant. Now we are substituting this one. Therefore, enzyme substrate complex equal to enzyme concentration into substrate concentration divided by Km. This is considered as equation 5. The total amount of enzyme considered as ET equal to free enzyme E plus enzyme bound enzyme substrate complex. So enzyme total concentration equal to enzyme concentration plus enzyme substrate complex concentration. From this equation 6, free enzyme concentration alone means total enzyme concentration minus enzyme substrate complex concentration. Now we are substituting the equation 7, enzyme substrate complex equal to ET minus enzyme substrate concentration into substrate concentration divided by Km. This is for equation 8. Now the equation are rearranging. Enzyme substrate complex equal to ET. Here we are enzyme substrate complex multiplying the common one substrate concentration. Now we are get enzyme total concentration into substrate concentration minus enzyme substrate concentration into substrate concentration divided common one Km. From this equation, enzyme substrate complex equal to Et concentration into substrate concentration divided by common Km minus enzyme substrate complex concentration into substrate concentration divided by Km. The common Km we are subdivided one. From this equation, we can collect like terms with respect to enzyme substrate. All the enzyme substrates goes to one side, remaining are another one side. Enzyme substrate complex plus the right side one enzyme substrate divided by Km goes to this side. Enzyme substrate complex plus enzyme substrate concentration into substrate concentration divided by Km. The minus this one goes to this side means plus 1. Remaining are equal to K enzyme total concentration into substrate concentration divided by Km. This is for equation 11. Here multiplying both the sides by Km. We are now multiplying both the sides Km means the divided Km will be striked out. Now we are getting the enzyme substrate complex multiplying Km plus enzyme substrate complex into substrate concentration. The divided Km are removed it equal to enzyme total concentration into substrate concentration. From the equation 12, the enzyme substrate concentration or common one we can take out. The enzyme substrate concentration into Km plus substrate concentration equal to enzyme total concentration into substrate concentration. From the equation 13, again rearrange it. The enzyme substrate complex concentration equal to Et concentration into substrate concentration divided by left side Km plus substrate concentration goes to right side means divided 1 divided by Km plus substrate concentration. Enzyme substrate concentration equal to Et into substrate concentration divided by we can rearrange it Km plus substrate concentration now substrate concentration plus Km. From the Michaelis Menten model of kinetics, V naught equal to K3 into substrate constant enzyme substrate concentration. This is for initial velocity. From we are already find out this one. From this enzyme substrate complex equal to V naught divided by K3. Also maximum concentration V max equal to K3 into enzyme total concentration. From this equation Et alone Et equal to V max divided by K3. This is for equation 17. Now we are substituting the equation 7 in equation 15. Again we are writing equation 15 enzyme substrate complex equal to enzyme total concentration into enzyme substrate concentration divided by substrate concentration plus Km. Here this in equation 15 the equation 17 now substitute it. Enzyme substrate concentration we are substituting V naught divided by K3 equal to instead of enzyme total concentration V max divided by K3 into substrate concentration divided by substrate concentration plus Km. Now multiplying both the sides by K3. We are now multiplying K3 means the divided K3 both the sides will be removed. Now we are getting the V naught equal to V max into substrate concentration divided by substrate concentration plus Km for equation 19. Finally, the V naught equal to V max substrate concentration divided by substrate concentration plus Km or otherwise Km plus substrate concentration. This is the final equation of Michaelis Menten. Next move on to significance of Km and Vmax. The Km value is used as a measure of an enzyme's affinity for its substrate. The lower Km value, the higher the enzyme's affinity for the substrate, and also vice versa. The Km value also provides an idea of the strength of binding of substrate to the enzyme molecule. The lower Km value more tightly bound to substrate is to the enzyme for reaction to be catalyzed, and vice versa. Vice versa means the Km value low means higher affinity. High Km value means lower affinity. Km value indicates the lowest concentration of the substrate concentration the enzyme can recognize before a reaction catalysis can occur. An enzyme's Km describes the substrate concentration at which half the enzyme's active site are occupied by substrate. Km value is also used as measure of the substrate concentration when the reaction rate of maximum velocity, I mean 50%. The Km equal to substrate concentration at which half of Vmax. The maximum rate Vmax reveals the turnover number of enzyme, that is the number of substrate molecules being catalyzed per second. This varies considerably for 10 in case of lysozyme enzyme, 6 lakhs in case of carbonic anhydrase enzyme. Thank you.